Well, why should we care about trust in clinical evidence? Well, if you think about healthcare, trust is fundamental to good medicine. Patients trust that clinicians have their best interests at heart and are using the best, most up-to-date evidence to guide what practice decisions they make with them. But clinicians are trusting that healthcare researchers have collected their data, have conducted their studies, and are reporting their research in a fair, transparent, and trustworthy way. And there's an awful lot in that research process of bringing evidence to practice that we based on trust within our community.
So if we're considering whether a study is trustworthy or not, we should think about what factors would make a study more or less trustworthy. And on the slide here, you can see some of the key factors that will feed into that. The first is research governance. Was this study really conducted to modern standards of good research governance? So for instance, can we be clear that ethical approval was obtained from an institutional review board? Has the study been pre-registered in the public domain? Is there a protocol that we can access as independent observers to make sure that what the scientists, the researchers plan to do is what they ended up reporting on in a full and transparent way? The next section is more familiar to most people. When we look at clinical trials in systematic reviews, we'll evaluate their methodological rigor or their risk of bias. Did the study control for known biases in a way that is reasonable and leaves the study at low risk of bias? But we're also interested in transparency. Is that study reported fully to modern standards of reporting? Does it follow reporting guidelines? And so that we have the transparency required that we could replicate that study independently. The next question we might ask is, are the data plausible? There always has to be space in science for extraordinary results, for outliers, because that can drive scientific discovery. But where we have studies that produce results that are really widely divergent from the rest of the field or really extreme, well, that's an extraordinary claim being made in those data, and that requires extraordinary evidence. So, if we have a study that is a real outlier in its field, we might use that as a yellow flag that we need to scrutinize those data further. And finally, we would be looking at the transparency of the data. If we think about what we can often see in a published report, it's a summary of the data, but we don't have access to the individual patient data underlying that summary. The movement of open science is to much more sharing of open individual patient data from clinical trials. But we would hope that upon request, we might be able to get access to that data so that we can check the claims that are being made in the scientific publication.
We can think of problems of trust as existing on a continuum, and Mark Bolland and colleagues recently presented us with a model for this, where problems that affect the trustworthiness of studies exist everywhere, from unintentional errors to intentional problems, from error all the way through to misconduct and complete fraud. So if you see the image on the slide here, we can see errors that will creep into anyone's research, potentially typographical errors, analytical errors, and then more concerning problems like undeclared conflicts of interest, all the way through to the extreme end where we have data falsification and data fabrication. There are lots of examples historically and recently of where science becomes untrustworthy. The Retraction Watch database is a really good place for people to go to read up on some recent and past examples. One of the most famous examples in the field of pain management is Yoshitaka Fuji. He's the single most retracted author in the history of Retraction Watch and was a Japanese anesthesiologist who conducted a large number of trials looking at post-operative nausea and vomiting. 183 clinical trials from that author have now been retracted from the scientific literature on the basis that the data were found not to be accurate. More recently, we've been living through the COVID pandemic, and we'll have all seen in the news stories about hope for new treatments, some treatments which have gone on to show real benefit, but others that perhaps haven't. And ivermectin is a really good example of that. There were many early trials of ivermectin making great claims that it was an effective treatment for people with COVID. And some of those trials have been found to be untrustworthy, to have data or methods that we really can't support. And the most reliable data around ivermectin suggests no benefit at all. Much more recently, our own group have been exploring some clinical trials in psychological treatments for low back pain, and have explored a group of trials from the same group with very extreme results compared to the rest of the field, suggesting enormous benefits for cognitive behavioural therapy for persistent pain. And we've raised multiple concerns in our investigation that those trials may not be trustworthy. And what's important about this is, if you think about all those examples, they're all for science that changes the care that people receive when they present in hospital to their doctors for a clinical condition. So there are high stakes here that we need to make sure our evidence is trustworthy. Well, this is one of our biggest challenges, is that methods for identifying fraudulent or fabricated data particularly are in their infancy. And so we're all exploring new ways to look at data to see if we can trust them. So recently, the reappraise checklist was developed. That's a checklist largely for journal editors to get them to ask a series of questions around research governance, data transparency, authorship and other aspects to see if a study that's been submitted to a journal flags any concerns over trustworthiness. The Cochrane Collaboration's Pregnancy and Childbirth Group have recently developed a tool that they routinely apply to clinical trials that get into their Cochrane reviews that looks across the features of those trials to see if there are any kind of red flags that identify that there should be concerns over the trustworthiness of those trials. And importantly, that tool involves and requires correspondence with the authors of those studies that we're concerned about, to give them that opportunity of a right to reply and to share their data to hopefully alleviate our concerns. But any tool that we develop needs to meet those features that we talked about at the start: governance, methodological rigor, transparency, and plausibility. And there's still a lot of work to be done to give us the tools to routinely forensically examine clinical studies. Open science potentially affords us the methods, the processes and the architecture to really alleviate these problems at source. If as a community we come together and embrace open science and develop open science resources, then we really leave much less space for doubt, much less space for trust, in the sense that we don't have to take these things as articles of faith. So if we think about what that means, it means open pre-registration of all of our studies. It means open methods. It means leaving our data open wherever possible for others to scrutinise. And open access publication puts all of that in the hands of the people who would want to use it. So it removes the barriers between the people doing the research and the people using the research. But it doesn't mean that process is reliant on just trust alone. And I think it's fair to say, if we look at the history of recent science, that taking science on trust is unhelpfully naive. Well, currently, trust isn't at the forefront of the conversation around clinical science, and I think we need to start more routinely looking at it. What makes evidence untrustworthy could be a range of things. What makes evidence trustworthy? The same. And we need to take a multifactorial approach to looking at it. We actually don't know the scale of the problem. We've identified, and today we've talked about some specific cases, but that could just be the tip of a much bigger iceberg. And unless we routinely look, we could be basing clinical decisions on data that can't be trusted. There's a lot of work to be done yet to develop our methods for better investigating the trustworthiness of our data. But I'm confident that at the heart of that, embracing open science is one of our strongest tools, because it's open science that will create the architecture for us to have a much more trustworthy evidence base.